This is Liminal Portal VR, a VR puzzle game for the MetaQuest 3, built in Unity, with a custom rendering pipeline, non-Euclidean portal mechanics, and forced perspective puzzles. Let's get into how it actually works. First, build setup. The project supports 2 target platforms out of the box. Under File, go to Build Profiles. You'll find a Windows profile for PC development and a MetaQuest profile for on-device deployment. Switching between them is just selecting the target and, if the modules aren't installed, clicking Install with Unity Hub to pull the right build support package. On the Android side, the project targets MetaQuest 3 via the Meta XR SDK v60 and OpenXR. Minimum API level is Android 10, API 29. Once those modules are installed, you're one build and run away from pushing the APK directly to the headset. One critical step that's easy to miss: the scenes in build list. Every scene you want playable, museum, desert, industrial gallery, has to be manually added here. If a scene isn't in this list, it won't be included in the build. You can still open it in the editor, but it won't load at runtime. The scenes are connected through a custom transition system built around what we call the intrinsic sphere. It's a trigger volume, a sphere collider, with a scene load script attached. When the player enters it, it loads the next scene. The pattern is intentional. Every scene ends with one of these spheres, which you configure to point at whatever scene comes next. The cycle just continues. 2 things to remember when extending the project with new scenes. First, every new scene needs one of these transition spheres configured with its destination. Second, and this is important, every scene needs the sample player prefab dropped in. That's the XR rig. Without it, there's no player, no camera, no interaction. It also needs to carry the player tag or the physics, and interaction scripts won't find it. The portal system is the technical centerpiece of this project, and to our knowledge, the first open source recursive portal implementation built for Unity's universal render pipeline. Each portal is a free portal prefab with one key field, the exit portal reference. You assign another free portal object there, and the 2 become linked. That's how the rendering knows what to show through the surface. The destination portal's camera view is what gets drawn. Under the hood, this works through stencil buffer rendering. The portal surface writes to the stencil buffer, and a secondary camera, positioned and oriented relative to the exit portal, renders only within that stencil mask. Custom command buffer classes handle the GPU draw calls directly, bypassing Unity's default camera rendering overhead. Those command buffer files you'll see at the repository root, compute command buffer, raster command buffer, and their interfaces, are the low-level plumbing for this. They issue stencil passes and compute shader dispatches independently of Unity's render loop, which is what makes the portal rendering stable at 90 frames per second on mobile hardware. Beyond basic traversal, the free portal script exposes a gravity modifier. Enable it, and when the player steps through, the gravity vector flips. The physics layer handles this gracefully. The XR rig's movement and the object physics both respect the new gravity direction, so grabbed objects fold the right way relative to the player. When 2 portals face each other, you get recursion. A portal inside a portal inside a portal. Visually, it should look like infinite depth. The naive implementation, actually rendering a new camera pass for every recursion level, scales exponentially with GPU cost. It's unusable in real time, especially on standalone VR hardware. Our solution is a 2-tier system. True recursion runs for the first n levels, configurable in the inspector. Beyond that threshold, it switches to what we call fake recursion. Fake recursion works by reusing old rendered frames. Instead of dispatching a new camera pass for the deepest recursion levels, the GPU is instructed to sample from a prior frame buffer at those positions. The result looks visually continuous. You still see depth, but the GPU cost stays flat. The forced perspective system is the superliminal inspired mechanic at the heart of the puzzles. When a superliminal object component is attached to a prop, grabbing it recalculates its scale continuously based on the distance from the camera and the player's viewpoint. The math projects what the object's apparent size should be at that position in screen space, then applies that as the actual world space scale. The result, you can make a small object enormous by backing away while holding it, or shrink a large object by moving toward it. When you release, the object keeps whatever scale it has at that moment. That retained scale feeds into the weight-based physics system. A larger object is heavier, can trigger pressure plates, and physically interacts at its new size. That connection between perspective, scale, and physics is what the puzzles are built around.